Okay, hello students. This is another dodged up episode of how to do reduction oxidation chemistry, this time recorded on a webcam, which I dodged up into my own document camera. So, you've got to be able to get the oxidation states of the same element in several different forms. Today we're looking at sulfur. So we've got H2S, S, and H2SO4, S2 minus, HS minus, SO2 and SO3. And in each of these cases, we want to get the reduction oxidation or the redox number of sulfur. So we've got to follow the rules. And if you follow the rules every time, you'll always get it right. So let's take a look. Let's take a look at this first one here. Hydrogen is always accorded +1, unless it's in hydrogen peroxide. Sulfur dihydride is not, or hydrogen sulfide is not a hydrogen peroxide, so we can do two of these is going to be +1 each, so it's going to be +1 and another +1, which must be to satisfy the overall covalent compound. Sulfur is going to be in a -2 format there. The monoatomic element by itself uncharged is going to be 0. If we look over here, each oxygen is -2, so you're going to have 4 times -2, which overall will be -8. On this side here, 2 hydrogens, so you're going to have +2 as a result. So if you got -8 and +2 and you put them together, overall you're going to get -6. So we're going to need to make sure that we can turn that -6 into nothing, because it's got to be 0 for the covalent compound overall. So that must mean that in this case here, sulfur's adopted a +6 oxidation state. If we look down here, S2 minus in an ionic form, monoatomic ion, yeah, it's going to be equal to its charge. So that's 2 minus. That's nice and easy. Over here, you've got a polyatomic ion because there's more than one. So this is the HS minus. You've got to make it so that it's equal to its charge. So whatever we add this up to, it needs to be equal to the -1 that we have here. Now hydrogen is going to be accorded a +1 in accordance with the rules because it's not hydrogen peroxide. So how do you go from +1 and then to minus? So this is going to have to be a -2. Because if you got -2 and you add a +1, then it goes to a 1 minus overall. So it's the sulfur's in the same oxidation state here as it is over here, and for that matter, over here. However, they're 3 different forms, and it's going to be in that oxidation state. So here, it's a 2 minus. Okay, sulfur dioxide, SO2. Each oxygen is accorded -2, and we've got 2 of them. 2 times -2 is -4. And overall it's uncharged, so this one must be +4, so sulfur in that instance is a +4 ion, and over here each oxygen is accorded -2, so we're going to go 3 times -2, overall -6, and that must mean for it to be uncharged overall, then the sulfur on this side must be +6. So in summary, we've got ourselves a -2, a 0, a +6, a -2, should be the minus on that side really, a -2, a +4, and a +6. There you go, that's how to do that. So I guess from here, it's up to you guys to give it a shot. Thanks for watching.